guys to Java Devs. Today we are going to look at yet another topic, something that I think in the industry, the way it's not used in a proper way, and we ought to use it in a proper way. Perhaps if that's the way you have been doing it, you will also have to rethink how you have been doing your code. And we're going to look at an array list. So an array list, guys, as you all know, it's an implementation of a list interface or iterable, and implicitly it uses an array to store the contents of its list. So under the hood, if I was to look at let's look at the definition. So we see here it actually has object arrays. It stores object array and it's given default capacity of 10. So if you do not specify the capacity, you get the default capacity of 10. So basically you can actually do something like this. I'm just gonna comment it. Maybe you can just give this capacity. So this is allowed. You can just say, just so you see, guys, this is allowed, perfectly allowed. So we are going to see what is the difference between this this way of instantiating an array list and the second way of instantiating an array list. You will see that both of these are different. They have performance differences that is very crucial, especially when you're dealing with that large data set. So without much wasting time, let's get into the business of explaining the details of the two constructors for instantiating a array list. So the first constructor, as we have seen, guys, let me just go into it. It uses the default capacity, which is size 10. So actually it gives you an array of size 10. But now what happens when you are adding your elements and the array that it uses internally gets full? So what it does, okay, let's check this add method. Okay, so we want to look at the array list implementation of add method. We see that we are adding, then we are growing here. Let's see this method, how they implement it. So as you can see here, guys, before you add elements, you must check whether the capacity is fine and whether the capacity is not more than the size of an array, so that if you're adding element and the array is already full, then you don't want to do that. You want to create a new list with a new length and copy all the elements of the old array into the new array list that you just created. So guys, that's it. So now, what is the problem with this kind of instantiating of an array list? The problem is that it will give you a default size of 10. When it gets full, it will actually increase it, and the way it increases the size, it's actually at half of the size to the original size. So that means if we have 10, it will add half of 10 and create a new array list with 10 plus 5, which is 15, and it keeps on doing that. And as it does that, it will take all the elements of the old array and put them into the new array. So we see that has a performance implications, obviously. But now this second implementation here does not do that, because here we are adding 5 million elements. There is never a time when this array will get full. So when you do this, you're actually initializing the initial capacity of this array list, which will mean that there's never a time when the crawl method will need to be called in this case. And this crawl method has performance problem because of the creation of the new array object. You copy all the elements in the old and into the new. So just here we have this code. I'm just going to run it so that you see that there is indeed performance implication. So if we run this code now, I want you guys to pay attention to the number of milliseconds here. So as you can see, I'm taking the time before the method gets completed, and then I get a time after it has been completed. And here I use serial processing so that the processing does not happen in parallel with streams. Those of you guys who are aware of streams, then I add each element into the list. Okay, that should be clear. The reason why you had to specify serial processing is because if we choose parallel processing, it means we are going to have many cores that are actually processing this data, which might reduce time and would make us not to see the differences between ArrayList, which is without an argument in the constructor, and the one with an argument in the constructor. So I'm just going to run this code now. Let's observe it in milliseconds. So we have 164 milliseconds. Let's run again. We have 162, 171, 158, 170, 165, 70, 66. So basically we can say the average milliseconds taken to process this, we can agree that it should be around let's just say 167, because it alternates between 170s and 160s. Now let's comment this code and uncomment this one and run it with this one, and we see if there is any difference. Wow, so we see that this one, it starts with 138. Okay, let's run it again. 133, 132, 130, 140, 133, 130, 135. So we can agree that this one now is 133 average. So already we see the differences in time taken for this code to be executed. You may be asking why. Because now the initial capacity is set to 5 million, and there's never a time when we will need to grow the array. And the growing of the array, as we have seen, has some performance problem. So as a developer, you must always avoid using this implementation, especially if you are dealing with data sets that is very high, that is very huge, and you would be inserting elements into the array list like frequently. Try as much as possible to set the initial capacity. That would actually substantially increase your performance. So we can see that the difference between these two is actually 30 milliseconds. This might also has to do with the kind of processor you're using. On my case, I'm using M1 chip. I am not sure what if you run it on another processor, what is the difference, but I think the differences would be relatively the same in terms of the processing time, because the algorithm, the way it has been designed for adding, growing and stuff, actually has some performance problem. It takes time to copy elements from the old to the new, and just like that. So guys, thank you for today's video watching. I hope you enjoyed, and please don't forget to subscribe.